Okay, I can see my Twitch. I'm waiting for stream elements to show. Just do some stretching for a bit. Yeah. So the plans for the day is the same. Oh, there, it's here now. Okay, so the plans for the day is the same as yesterday. I'm just gonna go back to learning Go, and I'm gonna put a timer, and let's do 60 minutes, 1 hour, right? Oh my god, I should have I'm sorry guys, I should have preloaded it. Yeah, this takes a while to load. Yeah, what did I do for the day? Oh, just, when you live alone, your free time is chores. What you do in your free time is just chores. Yeah. Did my groceries. Also went home. Visited home. That's about it. Yesterday was a Saturday, right? At least from where I live. What did I do yesterday? Aside from streaming, because I remember I streamed yesterday. I don't remember much what I did yesterday, aside from streaming. Uh, mm, yeah, because I streamed late at night, but like I woke up on the afternoon. I cannot remember. Holy sheesh. Maybe I have dementia, guys. It's not loading. It's not loading. Tomorrow, I probably won't be able to stream tomorrow. I have something that I have to do early in the morning. I usually on weekdays, since I have work, right? It's a weekend today, but like usually on weekdays, I have work, so I can only really stream in the morning. Around maybe 8. No, maybe 9. Yeah, 9 a.m. up to 12 before lunch. Up to lunch, yeah. Have a lunch, take a bath, and then work. That's usually my schedule. Tomorrow I won't be able to stream, but on Tuesday I'll try to stream. On Tuesday. Oh my god, it's really slow. Next time, before I open the stream, I have to remind myself to load it, to load the site. Golang docs. Why is it so slow? Why is Golang site so slow to load? And I'm not seeing any. Why is Golang website so slow to load? And you're not seeing anything. This is so unfair. Maybe FB, Facebook? No? Oh no. Golang docs load to load on initial loading. Actually, If someone in chat can explain to me why this thing takes so long to load, please. I need answers. I don't get it. I don't get it at all. Like if I go to Python docs, right? If I don't go to Python docs, it's like it loads almost instantly. See? Like this doesn't make sense. It doesn't make sense at all. Anyways, let's start the timer. Let's go do tour of Go. Where is it? Okay, I'll stop the timer for now. I need to find tour of Go. What? A video? What? Oh, no. That's not what I want. Oh, there. Tour of Go. And then let's put a timer. Okay. I'm done with this. There's this thing, right? And then I'm done with the basics. I think. I know. I'm here. More structs. I'm in pointers. Okay. I'm done with the full flow control. Yeah. There's exercise. There's no exercise here, right? Yeah, there's no exercise. I wonder if there's exercise here. There is. Nice. Okay. Let's just do 1R. Okay. Okay, who's pointers? Pointer holds the memory address of a value. It's like go to that. Yeah. So this variable is stored somewhere in memory, and then you're pointing to that slot in the memory. Okay, varp int. This is what I don't really get. Like, why is it a pointer to a type? This is one I get, because this is like you're going yeah, like P is like the address. This is like the address of I. So like P is like the address of I, right? And then print yeah, print, because if you print this, if you print P, you'll get the address. But like if you print go to P, which is like go to P, you get from the address, right? From whatever, go to this address, print the value of that address, and then you get the value of P. But what I don't get is this. What does this mean? I see it all the time. Like the type, pointer type, like I don't get it. I don't get pointer int or pointer whatever type. Anyways, the end operator generates a pointer to its operand. Yeah, it's the address. The star operator denotes the pointer's underlying value. Yeah. Points to the value. Points to the value, but based on the address. Read I through the pointer P. Dereferencing or indirecting. Unlike C, Go is no pointer. Help me understand pointer type in Go. Okay. Maybe ChatGPT might be able to help me. Let's go with ChatGPT. Okay. I get pointers and addresses and variables. What is it with star type? E.g. int x out for x, e.g. for x star int. Pointer to a type. When you use pointer type in a variable, it means the variable is a pointer a value of the given type. Hmm? Of an int. Okay. Okay. To create a pointer to an int. Yeah, memory address of y. Var y is 43. Address of y. Address of y. What if you, memory address of y? And, okay. Wait, I kinda get it now. I kinda get it, because if it's not pointer to int, if you put int, this will throw an error. This is an address. The value of this is an address, not an int. Okay. Okay. I get it now. Yeah. Points to y's memory address. If you modify the value of y through the pointer, that's interesting. Would you want that though? I'm not sure when you would want that. I know in structs, usually the use case for this is in structs. Like you directly work with the memory. Like later I'll show you so that it will make sense. So that you can manipulate the underlying values of the struct and not usually usually has to do when you have like structs inside functions, because like after the function call, the stuff gets garbage collected, right? So anything that you declare on inside a function, for example, if you declare the struct, like it would not change. The values of the struct will not change because it's inside the function. But like if you're modifying the I'll show you in code. I'll show you in code what I mean. Let's say for example, let's go here. May not go. Say for example, you have a type. Let's go with person. Type person struct a name. Right? Let's give the person a name string, and let's say this is from a database. So like int ID name. What else does a person has? Maybe account number. Account number. Or int something like that. And you have a function. Okay, it's kind of similar to this, but let's comment this out first. And like comment, right? Function main. And let's comment this out, align comment. Okay. So what I mean by this is that, let's say for example, I modify the value of person, right? Person.id is equal to, let's say, 1. And okay. Person format that, let's say, print ln say print f %v plus v, and then let's say this is a person, right? This is a person, so id is 1, name is John Doe, and let's give an account number of 1, 2, 3, 4, 5, 6, 7, 8. And then if we go around this, right, you get the thing. But if we print the function here, for example, you cannot do that. Ah, that's interesting. You cannot do that. Okay, let's put another function. Let's say test. This I already have a test function here. Okay, other func. And then we print it again. We print person again, right? We print person again. Format the printf person. Person type is not an expression. How about that? P person and P. But then, I'll be passing this. I wonder how you can print it not passing it. Oh, maybe I'll do this. I'll do this. Var p person. Yeah, and then p. Var p person. Oh wait, no, you can't do that. Var p equals person p p. Let's say p dot. This will be hard because it will change because I'm using a var to store it. What do I mean? Okay. Now I get it. Like how can I show it? So like let's say you have a func. It's like our func. Let me pause the timer, by the way. I'm just showing you guys. Let me pause the timer for really quick. Because I'm spending time on unrelated stuff. Okay. So like this is let's call this func1. And let's call this func2. Okay. And from func1, let's pass in person. No, we don't need to pass in person. We have this already, right? So let's say, for example, I'll modify p dot. I think it will get changed because this one is here. It should not be here, and I should be passing it. Okay. ID and let's say just put ID and name for now, and then let's print first. Didn't know you couldn't do this. How do you print the struct? Just the struct. Can't read the type. I don't know how to demo it, like just to show you guys what I mean, to prove a point. Okay, and then you print P, and then okay. How about I'll do this pre-person. Okay, I'll put this here, right, for our P person, and then I'll pass in P, and then I can do like p.id equals, let's say 2, and then I'll print P, and then I'll print P again, so that I can show you guys what I mean. And I can just comment this out for now. I'll show you guys what I mean. Okay, now fine. Finally, finally. Okay, so you see, like I've modified from the function the value of the ID, right? So this one will print a different person with the ID of 2, and then but this one will print person with the ID of 1, and I'll show you guys what I mean. See, the ID is 2, is from here, this first function, and then here the ID is 1, which is this. And I can even, like, to make it more clear, right? Maria Clara. See, Maria Clara. So like you modified this, you modified P person, but like you didn't actually, no, you didn't actually modify it. And yeah, you didn't actually modify anything, because after the call here and func, right? Funct1, it's garbage collected and it's gone. It's like it's gone. You pass in by value, and after here is like it's gone. That value is gone. Like it's, yeah. But if you pass in the address instead, like in func2, let's say remove comment, remove the end comment. Let's say I pass in the address of person, and then func2 is address of P. I mean the pointer to P, or is it address there? Okay, the address of P, right? If I pass in the address and I modified, right? If I modify that, right? Let's say ID of 3, and then stuff, and remove func1 for now. Remove the call for func1 for now, and what will happen with this is that it will print the same, like 3 and stuff. And the reason for that is simple, is because we passed in the pointer. I mean, yeah, we passed in the address, and then we modified it directly in memory. So this P here is the same as P here, but this P here is not the same as P here, because this is a copy of this. Yeah, it's not what's in memory. You pass in by, this is passing in by value, and this is passing in by pointer. Passing in by reference. Yeah, I don't know if you guys get that, but yeah, it's quite cool. Anyways, yeah. funct1p. Yeah, Maria Clara, name stuff, and it's the same. This is funct2 and then print. I can do /n. This is do funct1, funct2, main. So it's clear. It's clear. Yeah, Maria Clara. Anyways, that's the only thing I wanted to show you guys. Pass by reference versus pass by value. It's kind of tricky if you're not familiar with how pointers and addresses work. But if you guys want to know more about it, like you can go to CS50 and then CS50 and then they have like a course on it, CS50 memory, week 4. Just watch this video. It's not using Golang, but they use C. But yeah, the CS50X is goated, man. It's goated. It's one of the best, if not the best introductory course to computer science. Yeah, this video taught me a lot about how memory works under the hood. Yeah, you guys can watch it. I actually highly recommend it. Yeah. Anyways, let's go back here. So the type pointer T is pointer to T is various null. Okay, now I get it. The pointer type. It's a pointer to an int. I was confused at this at first because I was used to seeing this and the end this. I was used to seeing this, right? I was not using to star type. But now it makes sense. Point to I. Read I to the pointer. Set I through the pointer. Dereference, reference, and dereference. Get a new value of I. It can get really, really confusing, like if you're not used to it. But luckily, especially for web, you will not see this a lot, like in web, unless you're doing some very, very specific things, like very specialized fields. You need to really work under the hood if you want to squeeze in performance. Like maybe video, like when you're dealing with video streaming or editing, or like something along those lines. But for the most part, you won't be dealing with this if you're using web. But it's still good to know. I like to actually go deep in this because I as you know, it's like I know how I can recognize the shifting syntax, but like I don't actually know what it does. I know it shifts the bytes, but I don't understand what that means. It shifts to the right, it shifts to the left. What does that even mean? Yeah, but I wanna get to learn that maybe in the future, because right now I'm focusing on learning Go, right? But I also want to learn Rust in the future. Maybe in the future, next year maybe. But right now I want to focus on Go. Just go deep. Go deep in the language. That's what I want. Same thing how I did with how I learned Python. I just went deep. I mean, I'm not an expert on Python, but I know what I know. A struct is a collection of fields. Oh, this is like the data type of Go. Struct is Go. Yeah, you think in terms of data. I really like struct. C++, as far as I remember, also has struct. I don't remember if C has struct, or do you have to build it yourself? Because there's a lot of like data types that are like lacking in C. For example, in Go we have maps, right? It's not shown right now, but like it will be shown in the future. I'm pretty sure. I'm sure Go has maps. So maps are like dictionaries in Python. But in C, there's no such thing as maps. So you actually have to make your own. You have to make your own. Yeah. So I'm not sure. Let's see. Does C have struct? C have struct type? I'm actually curious. I don't think C has a struct type. Okay. Okay. C has struct. C structures. But I do remember C++ having one. Okay. Good to know. Am I just shitting myself? Yeah, there's no maps. Yeah, there's no maps or dictionary in C. Okay. But glad to know C has structs. Struct fields. You can think of it as like the closest thing to structs are like objects in JavaScript. But like it's kind of different. It's not really objects because it's not really objects, but it kind of is. Because the syntax, right, like v.x, there's like go to the x field of v, right? It's kind of like that in JavaScript. Same thing with Python, like when you're working with dictionaries, it's kind of like that, but it's not. It's not. Struct fields can be accessed through a struct pointer. To access the field x of a struct. Okay, dot explicit reference. That's interesting. Like quality of life. I did not know that. Structures are rush denotes a newly allocated structure. Okay. The special prefix and returns a pointer to the struct value. Okay. Arrays. The type nt is an array of n values of type t. Okay. Okay. So I was confused before, like where do you put the length of the array? Was it in C? Normally it would be like in C. It would normally you'd do something like int x and then the length, right? x10 is like the length of the array. So I was confused. The first time I saw the syntax of Go was like this, right? Var and then x, for example, int var x int var x int. I was like, where do you put this thing? I thought it would be here. Initially, I was like, where do you put this thing? Oh, it's actually here. And then you declare the values here. At least it doesn't Go, but like in C, it's like you declare the values like this. This is like the thing that also confused me a lot, right? In C and Go, because like as you can see, the list or the array, right, is like in brackets. This was confusing at first because I mean this is the curly braces, and then on C it's brackets. It's confusing at first because Python in Python, this means either a set or a dictionary. So I was like, yeah, why is this a list? So I was like, where do you put the value? Is it here or is it here? Is it like this? Yeah, initially it was confusing, but it takes a while to get used to it. But glad to know that this is where you put the limit. Yeah, next slide I'll assume is slices. Yeah, slices. fixed size. So this is like vectors in C++. An array has a fixed size, yeah, dynamically sized, flexible view. Practice sizes are much more common than arrays. A low bound and a high bound. Interesting. Creates a slice which. Ooh, that's interesting. That's interesting. That's so cool. That's so cool. Times 1 to 4. So elements, right, includes elements 1 through A. So this, if it starts with index 0, I'm assuming, so this should print this, right? 1, 2, 3, 4. 3, 5. Huh? 1, 0, 1, 2, 3. So excludes the last one. Okay. This okay. Excluding. I need this. I think this is the same in for all language, but yeah. I keep on forgetting it, like how this thing works. Slice. Var, let's say. No, we can do x. Var x 1, 2, 3, 4. So this is excluding, right? This is like low include high exclude. Exclude. So this is like access range of elements. Access range of I of elements. So this will print 2, 3, for example, will this print format that print prints no 2, 3. 0, 1, 2, 3. Okay. Slices are like reference to arrays. Slide does not store any data. Do you mean? Oh. Okay. Okay. That's actually interesting. So does the A will change. A will change. A will contain 0, John, Paul. And then this one will contain Paul, George. Right? But when you print this, John will be XSX. Yeah. Yeah. That's interesting. That's interesting. I mean, not John. B0. Paul. I mean, Paul is B0 here. Oh. References to arrays. I'm not sure if I like that. Yeah. So I guess just don't use two variables that holds the same slice. Because in other languages, it wouldn't be a reference. It would be a copy, right? If you do this in other languages, right? Yeah, it will be a copy. So like if you change B0, it wouldn't do anything to A. And I can prove that to you right now. I can prove that to you by creating a main.py, and then main. Okay, pi, def main. Okay, path. Let's say for example a equals 1, 2, 3. B equals. Oh wait, because the closest thing for a slice, right, is a list. Yeah, this is a list of strings. So this is names, for example, and then we can just copy this. This here. A equals 1, 0 to 2, and B equals 1 to 3, and then let's first print A, print. Why is it erroring? Maybe it should be this. I'm not sure why it's erroring. And names, right? Then not Pyron, but like go with pi main. See John Paul and Paul George, the same, right? John Paul George Ringo. This is the names. This is names. Oh, let's also print the names then. Print names here, and then let's print names after, and then we can add more information. This is A. So it's clear what's happening. Names, and then names. Okay, you can see it's the same. And then I'll change the B0. B0 equals, and this will not affect names nor affect A. Like it will only affect B. And see, this is how it is on Python. It's like a copy. It's a copy of the list, and this is A is a copy of names, right? A is a copy of names with these indexes, and then with this range of index. Same thing with B. B is a copy of names with this index. So like even if you change a B, it doesn't affect the rest. But like that's why I'm not sure how I feel about it when I see this and go, and it's like you change V and it affects everything. I'm like, I'm not sure how to think. I'm not sure how to, not sure how I feel about it. This is a good thing. It's like I can imagine a lot of things that can go wrong with this. Because it's a reference. It's not a copy. Yeah, it's a section of energy. Yeah, like I'm not sure. I'm not sure how I feel about it. Okay, but I think I want to take this. I want to note it down because this thing will bite me in the ass in the future if I'm not careful. Range. And then slices are references to base notes. It needs to be capitalized. So if I have like var a int 1, 2, 3, 4, 5, right? And then I have var int equals a02 and b var c int a0 country. This is reference. I say. We change b0 equals to 0. A would changes reflect to A and C. Formatted print ln a0 prints 0 prints 0. Yeah. That's why I'm not sure how I think about it. I have to note it down. Yeah, slash literal is like an array literal without the length. I'm just gonna check really quickly if my stream is still up. Okay, my stream is still up. Slash literal is like an array literal without the length. I thought array has a fixed size. Size is form by specifying this indices. Yeah. Slice does not store any data. Just this is wrong. This is wrong. Or ints. And this is also wrong. Yeah. Yeah. Dash draws. This is an array. Okay. Class defaults. When sizing, you may omit the high or low bounds use their defaults instead. Okay, with the size for the high bound. Slice length and capacity. Slice has both a length and a capacity. The length of a slice is the number of elements it contains. This is the number of elements in the underlying array, counting from the first element. Ah, interesting. This is the first I've heard of it. cap s. Like I'm familiar with len, I'm not familiar with cap. Slice, okay, capacity of the slice. Again, like I'm not sure when you'll be using this, because usually when you declare like a slice, right, that's like the main array. You wouldn't really split it much, I think. Like this is like very. I mean, this use case is very. It's not common, especially since you're aware that if you modify this, it will mess up the original slice. Yeah. Mm. Anyways, zero value slice as a null. So yeah, slices are nullable. That's what I've noticed. Yeah, slices are nullable because it's. Now I get why. Okay, now I get. So okay, I'm aware that slices are nullable because it's one of the most common use case. I mean, common use case. I mean, one of the most common things you could do in Go is you return a list of a struct. Like for example, like returning. For example, you return like people. For example, you return people, which is let's say for example, like you return you return person and then person. Why is it not working? Expected operand. Because people is not defined. Do I have people? No. How about not people? Type list of person. How do you return a list of person? But usually you return a list of the struct, right? And then if there's like an error, you can return nil. You can return nil and then the error. And I've always wondered why you can return nil. This is like a very common thing in Go. I always wondered why you can return nil. Because like you cannot do this if the type is like, let's say var error. Like see like it's letting me do it. Var error. Like it's letting me do it. But like if this is like a slice of ints, right? And not slice of structs. Oh wait, no, slice of int is okay. Slice of int, it's nillable, right? It's nillable. Nillable, it's still nillable. But like let's say for example, I'll change this slice int so slice of int, I'll just change it to int. And now it's not allowing me to do it. Because it's because int is not nillable. You cannot represent int as nil unless you make this a pointer, and now it can be represented as nil because this is an address. Yeah, it's really cool. So like a slice is a slice is essentially a pointer to an array, right? A pointer to an array. That's what a slice is. Pointer to an array. That's why it's nillable. It's really cool. Is a struct nillable? No, even struct is not nillable. Yeah. Zero value. So since struct is a pointer to an array, it is nillable. I mean since slices are a pointer, since is a pointer, since slice is a pointer to an array, it is nillable. So like func main, func name. This is let's say slice and you can return no. This Okay. It is nillable. Okay, so cool, so cool. Now it makes sense why it's you can define the type, the return type as null. Creating a slice with make. Okay, this is my first time seeing make. So make is like new. How different is make and new? What is the difference between make and new? Difference but make and new. Golang. Oh, is there a new thing? Excuse me, sorry. New allocates memory and returns a pointer to it. Okay. Okay, returns the pointer to the newly allocated memory. Okay, so type D. Pointer. So new is a pointer. Oh, zero is it. I wonder why you would use make instead of like just not, instead of I think I know why. Because you can specify the length and the capacity, and then it will be zeros. Yeah, it will be. Wait, let me confirm this. Let me confirm this. I don't really understand it. Let me comment this out. I want to confirm something, so let me comment this out. Just commenting it out, right? Add line comment. Func main. Let me confirm something. So var, let's say x equals var x int equals make int length capacity. So it's a list. It's a list of int. Make int length and capacity. Let's say 100. Capacity is 100. And then why is it erroring? It's not used a format that print ln x. Let me see. Yeah, okay. Now I get the use of make. Now I get the use of make, because like if you don't do this, right? For example, if you do what you normally do, and yeah, but what if you put like 100 here? Will it put 100 zeros? Now I don't get what what's the use of make. Now I don't. Yeah, I don't get the use of make, because you can also do this. It zeros it. I still don't understand. Oh yeah. The length is the length of the elements, the number of elements, right? So I kind of get it. I kind of get the length and capacity. Let's say, for example, have like, I'll put it again, and let's make this. How about let's make this 0, 100. Okay. Okay, so like if I put like, let's say 5 here, there will be 5 zeros then. 5 elements. But the capacity is 100. Okay, so that's why okay. It makes sense now. It makes sense. But what if I go beyond 100? Let's say 101. It errors. And swap. And it should not let me do it. Length and capacity swap. Okay. Interesting. Interesting. In Python, this is like cumbersome to do. Just initializing, you know, as an array, a list of like with zeros, a list of zeros. I mean, you could do it. You could do it in Python, sure. Like maybe something like x equals 0 for in range 100. That's usually how you do it. And then you do pi main, and then yeah, that's how you do it in Python. But it's really cool that you could just, you know, you could just do it using in Go, right? It's very easy to initialize something in Go and populate it with like values, populate it with like initial values, right? For ints, for example, it's zeros. So interesting, so interesting. So make, so make, put and make to create slice. A make type length capacity. So capacity, I can explain capacity here. Length is the number of limbs in R. Capacity is the limit or size of R. I keep on forgetting that it's this and 0 100 prints and then yeah. Okay. So cool. Slices can contain any time, including ours. So it's like a matrix. You're making a matrix 2 by 2, a grid. Okay. Create a TikTok board. Yeah, this is this is like the coordinates, like x coordinate and the y coordinate. So 0 0. 2 2 is like 0 1 2, and then 0 1 2. So here it's an O, and then 1 2 is like 0 1, and then 0 1 2. 1 2 0. What? 0 1. 0 1 2. I have no idea why this is 1 1 1 2. Maybe it starts. Does it start here? 0 1 2. Where does the coordinate start? Ah, okay. 0 1. This is 0 1. It starts here, okay, and it goes down. 0, 1, 0, 1, 1, 0, 1, 2. And so this is x. First one 0, 0, and then 0, 1, 0, 1, 0, 1, 2, 0, 1, 2, and then this is 0 here. And then 0, 1, 1, 0. Yeah, and then 0. It's this. And then 0, 0, and then 0, 1, 2. Yeah, it was confusing because it starts here, going down. Okay. Anyways, moving on. Appending to a slice. It is common to append new elements to a slice, and so Go provides a built-in append. Yeah, append, built-in a package append. Plus the provided values. The return slice will point to the newly allocated array. Okay. But I'm curious. I am curious. Oh wait, no. And S. There's no way. There's no way you could. Never mind. I was thinking of something, but there's no way you could do it here. Yeah, there's no way you could do it here because you're changing the pointer to the newly created slice. I'm not sure what happens to S, to the old one. I guess it gets flushed in memory, like it's gone after, maybe, probably it's gone because this is like your new slice. This one is gone. I'm not sure, but I'm assuming that's how it works. The range form of the for loop iterates over a slice or map. Okay, so for is the same as while and go. I'm aware you can also use range. Well, when ranging over a slice, 2 values are returned for each iteration. One is the error. No. Okay, no. It's the index and the value. Index and the value. Yeah, index and the value. So cool. In Python, it's not like that at all. In Python, it's like, I'll show you. Like if you have like this list, right? If you have a list of like 1, 2, 3, 4, and then you loop over that for I in X. Then you print I. It's not the index. What gets printed is the elements of the array, right? And if you want to get the index, you need to. I actually forgot how. I guess it's like for I in range X. I assume it's like for I in range len X. Yeah, and that's how you get the index. This creates a new list. Range creates a list of the length of this. So if the length is like 4, it creates like a list of 4 elements. So 0, 1 starts with 0 by default. It starts with 0. Yeah, the default start is 0. And then you get the indexes 0, 1, 2, 3. So yeah. Usually the thing that this shows, right, to get access to the index, even in dictionaries, list, yeah, you have to do something like this in Python. But like I'm kind of glad that the range in Go by default returns you the index. Because like a lot of times that you're like, I don't really need the index, but like I think more often than not you need the value of the index. Yeah, you need the value of the index of the list. I mean, it doesn't happen too often, but it happens a lot. it's not as common as just needing the value. But yeah. So range returns. But I wanna just write it down. Range returns by default. I already know this because I've used range in Go and on a project. So for range iterates slice and map returns index value. So for I index, for I the range iter. Yeah, something like this. You can skip yeah. Underscore. This is common in Python. The underscore, like if you're not using the variable, but you know, I've shown this before in Python. This thing. Oh, already been for like you could do for next in range 100, for example. This creates a list of 100 elements. Oh yeah, you could just do a range 100. But anyways, to initialize something, and then print x. You're not really using the variable, so like you just put an underscore. Yeah. Oh wait, no, you can't use range 100 because you want, yeah, you want the values to be 0. In my case before, 0, 0. Anyways, range borrow. Now this is like interesting because normally you if a function returns a tuple, or a tuple in Python is like kind of like a list, or like multiple values. If the function returns multiple values, right? You normally you wouldn't be allowed to do this. This is like the syntactically correct thing to do, but I'm surprised Go allows you to do that. The for I. If you only want index, it's valid. Not throw error. That's interesting. Like, say I have a make ints 100. Oh, just 5. Let's just 5. I range x. Now let's say x. For x, x. I still cannot justify I still cannot justify the use of make. Okay, I'll finish this, and I'll just finish this up to 27, and then I'll call it a day. 2, 3, 4, 5. Print format. Print. No, I'm surprised this is allowed. Syntax error. Where's the syntax error? Huh? Non-declaration sentence outside function. Maybe, what's wrong with this? May not go. Hmm? I guess this is not how you declare. I guess this is not how you declare slices. Is my rules wrong? This is wrong. Okay. Okay. I was thinking of like maybe an interface, yeah, or a struct, like a person struct. I guess it is not how it works. So like you do this instead. I wonder how you initialize or something like this. How do you initialize an array? Is that the use of make? Array Golang. Ah, this one loads so slow. I hate it so much. Why does this work? Ah, I know. I understand why that works, because var x and then the type of int type, right? And then you do this. This will work. Okay. So assuming that this should also work, right? Ah, okay, okay. That's how you do it. Okay. Okay, this is the index of 0, 1, 2, 3, 4. Okay, so this one shrunk. Var x var x and okay. Yeah, I was right. This is how you initialize it, but like I was doing it wrong. I'm glad I caught that in my notes. Interesting. You can just do range. Just slice less. Implement pick. It should return a slice of length dy, each element of which slice dx. 8 bit. You run the program. Pick. Unsigned integers. Okay. When you run the program, it will display a picture. Grayscale. Blue scale values. Pick that show pick. It should return as implement pick. It should return a slice of length dy. It should return a slice of length dy. Okay. This one is what do I want to call it? Slice. Is it okay? Slice dy. Slice of length dy. So vars. What's the type? Uint 8. It should return a slice of length dy, which is a slice of dx. Slice of length dy. So make. Can I just return the make? Just return it. Uint 8 dx slice of length capacity, right? And then which is each element of which is a slice of dx. Length dy, so like this. Each element of which is a slice of dx. Slice. Each element of which is a slice of dx. So it's like for I, no. I need to return ival range dy, but dy is an int. Dy is dx. Each element of which dx is an int. Dx, not dy. Dx is an int, right? It's an int type. It's not a slice type. So I'm confused. I'm really confused right now. Dx is an int. Each. Maybe for ival and range dy slice I dx. That is this what it's, I don't know. I don't know the what. Don't know what it's trying to do. Oh, I cannot do this because it's nice. Declare not use val. Can't use dx variable of type int. Should return a slice of. You need to use a loop inside the uint 8. It's not append. I don't understand the problem. Implement pick, it should return a slice of dy, each element of which is a slice of dx. It should return a slice of dy. It should return a slice of length, each element of which is a slice of dx. Okay, so I have temp, which is slice with length vy. No, I just already go with temp. Uh, each element of which is a slice of dx. Each element of I forgot how you make a matrix again. Page up. Creating a slice with make. Slice of slices. Slice of slices. Okay. Slice of slices. So you append it, right? So like I can do like slice. Return a slice of length dy. Not capacity. Yeah. And then after that, since it's how do I say it? Since it's a matrix, right? So for I this is small slice. Slice. Piece. Small slice. Range slice. And then for J small slice. Or something. Mm, I don't even know what this does. So let's go to Go. I don't know what this does. Let's say 100. What will this do? I'm curious. Okay, so it's a slice of slice, right? So I've done that. It's a slice of slice. Then what do I need to do with that slice of slice? When you run the program, each element is a slice of dx, 8-bit signed features. Really like small slice. Here it goes to you and oh, declare the not use. Index of range 0. There's nothing in it, right? There's nothing in it. Okay. Hmm. Hmm. I'm thinking of doing something like this then. A small slice equals to the x. U int 8. U int 8 the x, right? And then for I, slice. Right, so I'm done. Yeah. Temp small slice. Slice for small slice range slice. I just need to append temp small slice, right? Right? Not small slice. Take this, right? It should work. Let's make int 8 dy. Should work. Oh, it int 8. Undefined. Why? Why? Cannot use temp small slice as the int. Huh? As the what? Small slice. Mm, maybe not append. Maybe like I. And then instead of using I, you can do this. assignment. I wonder what's the type of small slice? Print f percent %t sorry, okay, I'm just lost. Defined format port. Didn't even format it. I don't know the type of the. Look at this small slice. Yeah. Sorry, okay. Compiler is complaining. Uint 8. Is there like a break statement in Go? Break statement in Go. I'm just curious, okay? And it takes a while. Okay, there is a break statement. Sometimes the compiler is against you. Because I don't have an IDE. See, it's the same type. It's the same type. It's the same fucking type, okay? It's the same type. So why is it not working? Wait, does no range is for length, right? Range is for length. Golang, does range go over elements or capacity? Lengths or capacity? It's therefore. I'm curious. I can just do it here. So like I have a, let's say, make ints 0 100 and then I slice format. Slash I. Okay, it goes over the length. So if I have 5 here, it should give me 5 elements. Yeah, the index of the 5 elements. Okay, it goes over the length. It's not the capacity. Okay, it goes over the length. This one I'm still I want to die. So I can copy this. I can maybe do this, right? Maybe, and then 1, 2. No. dy. Let's put dy 100, and we can do 1. Okay. And 8. Okay, this is good. This is good. Yeah, I get it now. Put this here, and you get not used. I guess I can just format that print. Hmm. Hmm. Maybe it's like nice I. But this will be wrong. Okay. For some reason this works. Oh, important not to use. Index out of range in length 1. I wanna do this, like package main. Maybe because I don't have the package, that's why I'm struggling, because I don't have the package. So like maybe if I here cd 0 of go exercise to mod net example. Hmm? I haven't. I wonder what's this ffunc txt. What's the length? I wonder what's the length of it. Each element of which is a slice. But maybe we don't know. The elements, number of elements, right? When you run the program, it will display. Solution. I give up. I give up. I don't understand the problem. That's the issue. Okay, size of index. Capacity. Hmm. I want to see the solution. Okay. Index. Okay. This is how bad I am in matrices. Yeah. Mm, I'm gonna copy this. I cannot comment it. Sag. Let me understand what happened. You create a slice. Same thing here, that the thing that I did before. For Y range back. Actually, I can go over this. I can do this, right? So we can understand it together, chat. Because I'm confused right now. I'm like lost. Yeah, my stream is still running. Yeah, my stream is still up, so we can just do this and then breakpoint, run in debug. Put the breakpoint here. Let me debug. Okay. How do you next? It's a shortcut for this Shift 11. I cannot do that because I'm using a. Yeah, I cannot do that. I cannot do that because I'm using a 60% keyword, which sucks. So I have to. Again, let's do it again. Oh, let's go here. Let's go directly here and then run this debugging thing. Okay. Then no, because you did not specify the length. There's no length. There's just capacity of the 56 bytes. 56, okay. And this one, pick is this, right? Y is no 0. Why is Y 0? Why is Y 0? Oh, this one I'm confused because you made this. Ah, this is the length. This is not capacity. This is length. Okay, interesting. So nil, but it's actually 0. Like it has elements inside it, right? Right? Yeah. Can I see the? It has elements inside it because it's the length. The 56 elements inside it. And then so Y will have a value. So pick Y. Okay. Make for every element of pick, which is we can maybe go to Xcolor Draw. I want the dark theme. So we have pick here. Pick. Can I get like a structure? Okay. I have pick. No, it's this. Pick is like this. Oh yeah, slices can be nillable. That's why it's nil. It's showing nil because this is a slice, which is a reference or a pointer to an array. Then this is like 56 elements. The 56 capacity cap. And then once we're here, we're the first index, which is this. So pick I, right? Which is this thing. You make a new dx. You make a uint a dx. Is it a list? It's a list, right? It's a list. Yeah, you make a list. Okay. No one saw that. So you make a list of the 56 elements, so like it will be 0. Nillable. And then this is like the 56 cap, right? Right? We're still here. So yeah, this so pick Y. 70 should have the 56 elements. Yeah, pick Y should have. Pick Y, yeah. See, it's like 0, 0, 0, 0. 0, 0, 0, 0, 0. Okay. Pick Y has 0 elements, and then pick YX. You just X plus Y. Okay, you have this we have this formula which is I think here. Okay, it's not there. but I can replace it with something. Like I can replace it with something else like this. Yeah, gradient. That's interesting. Okay, but this is the thing that, yeah, this thing doesn't matter. Like this thing doesn't matter. What matters is this. Okay, but like now that I'm visualizing it, it makes a lot of sense. It's like when you're looking at code, right? You're trying to wrap what's happening in your head, and a lot of times, like maybe my brain is just small. I have a very small brain, and I cannot wrap myself. I cannot like imagine it in my head. I have to write it down. I have to go to a breakpoint. I have to visualize it because otherwise I wouldn't be able to understand what the hell is happening. Or even if I did understand, if I understood this like the first time I saw this, right, that would mean I've written something similar before. But because I don't understand this, that means I haven't. I've worked with matrices before. Using C++. But that was like a very long time ago. And it's like kind of, I'm still like kind of, how do I say it? This make thing threw me off guard, okay? I was not on my game. This make thing threw me off, okay? Even though I kind of get it at the same time. I don't get it, but like now I kind of get it, I think. I need another exercise, like something similar to this, so that I can fully understand this. So maybe let's do an exercise, like go with make exercise. Golang. Okay, there's none. Exercise to practice. I want some exercise. Thank you. Do I need to pay? I hate it so much. Like, can I? Is there like a free version of this? A free version? Free version? Okay. This is a matrix kind of. This is easy. This is easy. I think I can do this. I think I can do it. I'm not sure. Okay, so import format. Oh my god. Did I just kill OBS again? I want to do it. I wanna redeem myself. I'm so bad, and then I wouldn't be able to solve this, right? Okay. Funk man. Let me stop this. This is already exercise 3. I don't need to do this. Okay. Maybe. Yeah. Let's go. Already have it. So func main. Okay. Okay. So obviously we need an input, right? So I don't know how to input first, like input and go. So I wouldn't do that. So I'll just how do I say it? I'll just accept an input, a letter. So let's say diamond, and then letter, like A. Yeah. So func. Let's do this. Func diamond S string. Okay. Then format the print or something. Okay, but now I need to how do you get the how to convert alpha to num Golang? Oh wait, exercism. Ah, oh my god, I forgot the exercism Golang. It's done. Oh no. Where's diamond? Diamond. There. Okay. The last row. Okay. Rune. I just do this. No, no, the string. I want a number to charge the R. I want number. I mean, I want string to the number equivalent of it. Into letters. No, no. Yeah, alpha. No, 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 not alphabet. Number representation of an alphabet. How to get the equivalent number of character? Okay. Int in. Rune a+1. Why? Can't you just do rune a? In minus a+1. It's interesting. Or this one. And then subtract by 64. 65 SK. Okay. But I can just do to upper. As strings to upper S. Strings. What strings that? Yeah, to upper S. So even if I char C string, since I'm dealing with char or S string. Can I do no. I can't is there like a Golang representation of char? Representation of char. Or is it just string? Ah. Oh. Oh. Okay. Derivative is sor. Ruin. Yeah, 1 character is 1 byte. Okay. But that's not what I'm looking for. Anyways, I don't know what's. So it's not rune. It's not rune. I don't really care. So what is I? This is, maybe not. Okay. Maybe rune. Then rune. Hmm? Oh wait, no. I'm dot. It's important not use 1. Okay. I have 1 now, and then var s string. Okay. What's the thing? So I have it now. Okay, so what's important here is you know the value of it. So if it's 1, you just return immediately. If it's C, it's the number of gaps, like 1, 2, 3, 4, 5, 6. Never mind. It's not. I guess it's like 0, 1, 3. This is 3, and this is 5, and 7. Okay, that's important. That's important. That's the pattern that I'm seeing. 4, 5. Okay. I'm also seeing this pattern. Like 4, and then middle, and 4. So it's like times. No, it's not times 2. It's like and it's always even, right? It's always even. 4, 4, 1. So it's like the length times 2 minus 1. Length of 9. Yeah, 9 E. And then for C it's like 3 times 2 minus 1. 6, 5. I think that's important. That's like the width. That's like the width, right? The width. How do you get the length divide times 2 divided by 2? Oh no. Times 2 minus 1, that's the length. And then C, the value of it minus 1, and then letter, dot. Okay. This is not hard. This is not a hard problem. I can easily do this. Okay, I've solved harder problems. It's just it's been a while. It's been a while since I've solved like problems. It's usually just patterns. You just need to replicate I just find a pattern and then just code it. How do you find? Yeah. It's like once you figure this out, right? You can just mirror this. This is easy. The bottom part. This part is the thing that I need to figure out first. I'm still thinking about it. Four, 1, 4, 3. Okay. So something must be. So let's do with left upper left left is this is and I like the representation of a num. Okay. And then the width is num times 2 minus 1 times 2 minus 1, and then it's the width and then so I just need to and then the and then how do I make it so that it always starts with A? I guess I need num to char. I need num to char. I mean, yeah, num to char, num to alpha. Golang. Okay. It's char and then char string. Char. Where's the chars there? Num. Hmm. Ah, why am I? Num C. Okay. Okay. I'll have to char. can just do this. Or not. Okay, so I have this. I need to make a slice. This is like a slice of slice, right? What's the length of it? 2, 3, 4. It's kind of the same. It's a box. It's actually a box. Yeah, it's the same. So this is like the size. Okay, 9 times 2 minus 1. That's the size of it. So we create a diamond. Dia box or a box. Just to make there string of size, and then for I in box range box, or not box, square. So it's actually a square. It doesn't look like a square, but it's actually a square. Run range square. So we have a string. S plus equals. Okay. This is row. And then for J row. Range row. Okay. For now, it's like this. And then now I need to two dots, right? It's 2 dots and then 4 dots. So that's 4. So that's like nom minus this one is like, let's call this pointer p. Let's p int and p nom. So like, yeah, let's have a pointer to nom, which is, for example, if this is 3, that's the third element. So for J range row, I'm s plus equals to dot, right? And then don't even need to. Okay, I'm not using J. And then row J. Var s we can dia and then s and then return dia. What dia? Row s, row J equals to square I square I equals to s. Do something like this. S equals to 0. And then J will not be used, I think. So I can just maybe, what's the length of, go again, I forgot how to get the length. len s for j less than len row j plus plus. Hmm. Wait. Not this. I need to look at it again. The code before. Pick. It's above here. It's not here. Okay. This one. I don't have this. I should save this somewhere. Pick. Exercise. Exercise 2. Okay. Because I'm confused. Oh, okay. I keep on forgetting that. So row ij. No, not row ij, but like slice ij. Slice ij, right? Not slice, right? Why? Maybe it's not. Maybe it's like a list of strings, not yeah. It's not. It's not a 2x2. It's a list of strings. It's a list of strings, and then instead of doing this, where I. X plus equals to X. This is like length, right? The square. And then here is like initialization, and then square I something. I don't really know what to do with J. I just need to iterate over square again. So maybe I can just do this. J equals to 0. J less than length square. J plus plus. This should create me, okay. P not declared and not used. Okay. This should create me a box. It doesn't. Okay, why? Hmm. If each should be, okay, it's 5 by 5, right? 1, 2, 3, 4, 5. I mean, like 1, 2, 3, 4, 5. And this is like A. Okay, at least it works. Okay. Easy. Like I still need to have the character show up. So that's by default s plus equals to star, but there should be a character to it. If j is equal to what? If j is equal to what? Num minus 1. P minus 1. So if, how about if j equals p minus 1? If j equals to p minus 1, oh, okay. To j? D. Okay. What's the I? I plus. Okay. 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 I have it. I have it now. And then now I need to put B here. Okay. And then P minus 1. Right? P minus minus. Okay. A, B, C, D, E. Now I need to put B again. If J equals P minus minus 1, P minus 1, P minus. I need to reflect this now. It's starting to take shape. I need to reflect it somehow. How do I reflect it to the right? Maybe I'll. Oh, and then instead of, yeah, like L and R, right? I think I can reflect it by doing L and R. And then R is here, right? I can start with num minus 1, so R num minus 1. I can do that. I can start R with num minus 1, and then I need to target this, which is times 2. Num times 2 minus 1, right? 1 times 2 minus 1, which is size. R is size then. Equals to size. So if j equals to size minus what? It's subtracting something. What does 3 mean? Maybe it's like size divided by 2 plus 1. Num plus 1. Yeah. Or equals to num else if j not plus 1, then says it doesn't work. R plus 1, no minus 1. No plus 1. Not plus 1. Else if j. How do I reflect that? I know it should be plus 2, right? But like, how do I put it to where I want to put it? Yeah, I want to put it down. But this is wrong. I know it's wrong. I have a feeling it's wrong. Okay, I have this. I was able to get this far. Okay. Let me draw it, the next color draw. So I can visualize it. So E, for instance. E, right? E is 5. So we have a 5 by 5. 1, 2, 3, 4. Letter. 1, 2, 3, 4. This is S. That's it. This is S or S minus 1. S minus 1. And I. This is I. And then 1, 2, 3, B. Dot S minus 2. I. S minus 2. Okay. And there's gap here, which is N. S minus I. This is S minus I. Yeah, this is S minus I. S minus I plus 1. Yeah, this is like if we set like, let's say, I, right? This K equals I plus 1 or not. Okay, let's make N. N equals I plus 1. This is S. So 1, 2, 3. I already know the solution. 4 is N. N is I. And then it's N plus 1. This is I. Oh no, this is not I. This is N. And N equals I plus 1. I don't know. This is how do I say it? This is s minus n, s minus n, s minus n plus 1. Then this is n, b is I, s minus n plus 1. Yeah, I just need to recreate this pattern. It's actually easier if you if I just, you know, if I just write it down. This is n. No, this is not n anymore. This no, this is n. This is 1, 2. But this is 2 though. So n minus 1. 2. This is 2. And this is 3. N. N minus 1 n. That's n minus 1 n plus 1. Or is it n minus I? No. This is n. Then this is n minus n plus 2. This is 4. N plus 2. No, n plus 1. So this is 3. This is 3 already. So this is 0. It's just 3. Yeah. And then 5 minus 3 is 2. Yeah, s minus n plus 2. Yeah. This thing here is tripping me. This thing. Like, how this thing, the thing in between, is tripping me because I don't know what to represent it. Oh, no, this is I. I don't know what to represent the thing in between. So it's like one dot, on 2, and then 3 dots. So 0, 1, 3. 0, 1, 3. It's odd numbers, right? I can also just what I'm thinking is I can build this. I can reverse the string. Like, I can just reverse the string. Go reverse string. Oh, you cannot easily do it. Okay, I was thinking just build the half, build this, and then just append it. But I guess, and then just the thing in between, you can just do this and then just replace the thing, right? Replace the thing. Just, but I think, I don't know. Okay, what's the pattern in between? That's my issue. The pattern in between is my issue. I know it's always 0, 1, 3, 5. Yeah, 7, 9. It's like always 0, 1, 3, and then it goes back to 1. But like in the next, no. I mean, no. C, D. It still needs to go to D. It's 5's next. So it's odd. But like, where do I get that? It's like n. And then n plus 2. N plus 2. N plus 2. It's like n plus 2, n plus 2, n plus 2, right? And once it reaches E, n to n, 2 times 1. No, it's n plus 2. Has to be, so 2n plus 2. Okay. So n, and then 2n plus 2 plus 1. 2n plus 1. Right? No, it's not n plus 2. This is s minus n. This is always s minus n. There's always s minus n if I is iterating, right? I is iterating and n is s minus n. This is always s minus n. Because n here is n equals 1, n equals 2, right? 5 minus 3 is 2, n equals 3. Yeah, it's always s minus n. This one here in between is I, this is I. I don't know what the one in between, like how do I represent it? It's s minus what? 2n? What is s minus 2n? S is the size. S is 5. S is the size, right? Yeah. D. N. I. Then here is minus n. If s minus n is 0, you stop. If f, yeah, this is e. S minus n is 0, you stop. But this thing keeps expanding. Like 4, 1, 2, 3. Okay, so how do 4, 5, 6, 7? Yeah. How do I represent this? This is not n. This is 2. Yeah, this is 3. There's a formula for this. Like to get the gap. Right? To get the gap. How do you get the gap? How do you get the gap? I. N plus n times I. 2 times I know. N plus I. I here is 2 though. Here is 1. I here is 2. What if it's s minus n? Inverse of it. Yeah, what if it's s minus n? So like here is like 5 minus 1. 5 minus 5 minus 1. Yeah. And here is like 5 minus 5 minus 2, which is 3. So this is 3. I should get 2 here. Never mind. I should get 2 here then not. Never mind. It's the wrong equation. Yeah, 5 minus 3 is even wronger. Because this is 2, and then I should get 3. I wonder what the equation is for this. I know it's like 135, 0, 135. So like, what if it's just 0, 1, 0, 1, 3, 5? Yeah. The relationship between 3 and 5, this is n equals 4, n equals 5. So this is like 1, 0, like 1, 0, right? Pair. And here is like 2, 1. Here is like 3, 3. And 4, 4, 4, 5, 4, 5. 5, right? Yeah, 4, 5. And then 5, 5, 7. Yeah, 0, 1, 3, just odd numbers. Just odd numbers, really. 0, 1, 3, 5, 7. It's like I need an iterator, just I plus 2, I plus 2, I plus 2. No. This is 1, 3. Here 0, I 0, 1. So it's not plus 2. It's not even plus 1. 0, 1, 3, 5, 7. I think I just need to have a separate count for this. Yeah, like even number, add numbers. Just create odd numbers. And that starts with 0. Okay. To the I can't see a pattern. I can't really see a pattern. 7. Here is like 9, 7, right? 7. What's the relationship between S and 7? Is it always plus 2? Or maybe it's like S minus N. S minus N, S minus N, and 2. But then there's A, right? Let me first do the things, like this thing, so S minus N. So N equals to 1. N equals to I plus 1, right? So N equals to I plus 1. S is the size. This is the size. Or this size SZ. Okay, I can just make this SZ. SZ. So SZ size. Okay, fine. I'll just use size. Size minus N. Size minus N. The size minus N here. Size minus N. If yeah, I'm really thinking, what if I just do this and then just reflect it? But then I wouldn't be solving the bottom part. Yeah, I wouldn't be solving the bottom part. Size minus N. Where can I put that? I have this as yeah. Or 0 j less than len size minus N j plus plus size minus N. Len size s plus equals to asterisk, and then I'll remove this first, and then let's see what I got. I'll declare but not used. Okay, I have this, which is kinda not really what I want. S minus n. Size is num. So it's not size. Z equals num. Okay, I'll just it's not num. So that's z equals num. Okay, I have this. And then now I have to reflect it here. Print and then s plus equals to char to stir I stir n. Okay, stir n, and then this one here, n should be equal to the opposite of should go back, right? It should reverse itself. It should flip. So it's not s minus n anymore. It should be s plus n. No. S minus. Maybe, yes, not square. Maybe I'll go with size. Something like this. Okay. Have it, and then now I need to reverse it, right? I need to reverse the thing. I need to reverse it somehow. Mm. 10, 10. It's not S anymore. How do I reflect it? Now I need to reflect this somehow. First, I'll do the half diamond up. I'll worry about it later. Oh wait, this is SZ, so I can just Yeah, I can just reverse it. I equals to sz, I greater than 0, minus minus. S is 5, right? So you start with 5, and then it's like 5 minus... Is it I? Is it the same? I'm not sure. Okay. Then it's n equals to I. Okay. What? What? Yeah. Instead of sz, I can do minus 1. And minus 1. Never mind. There. Okay. It's very scuffed. I know, I know. Now I need to figure out the thing. Oh my god. Now I need to figure out the thing after. Because I don't know the thing. That's his problem, is I don't know the thing. 01357 0135. So I need to make an array of how do you say it? An array of odd numbers. Okay. I need to make odd numbers. So I need to make an array of odd numbers. So odd equals make ints and then sz, the size, right? Size. This is size. Yeah. Up to 5. 0135. No, not really. Size minus 1. Size minus 1. So if size is 1, it's 0. Okay. And then for I equals 0, I less than I in range odd, index of odd I equals I. For I range odd I. This is X. I'm sorry. This is odd I. Odd X. Odd num. It's the 1. That's the odd num. If I not equals to 0, odd num plus equals to 1. num equals to 1 if num equals to 0, num equals to 1. Put this here. Else add num equals to. Okay. Convoluted way to create add numbers. So I have it, but I need up to 7. So size is not size minus 1, it should be size. Yeah, 0, 1, 3, 5, 7. Then I have odd now, right? So here, from here on, for range odd, s plus equals to star. J equals to 0, j less than ln odd, j plus plus. Okay, that was wrong. Oh, no, odd I. J less j. There. And then s plus equals to start in. This is if I equals to 0. If oh my god. Now I need to do it in reverse. I just find it funny. And this is easy now because I can just do this. Okay, what the hell? This one. Just repeat this. There. It's so funny. Okay. Okay. Now I need to do this, repeat this, right? I need to repeat this and put this here. But this will not be correct because, but I guess I can do. No, it's correct. This will still be correct. Yeah. This will still be correct, but I minus 1 then. There. It's so funny. Solved. Okay. As in now equals to ln size. But I not equals to ln size. Minus 1. Z minus 1. No, equals not. What? Is this one? Hmm. Okay. I not equals to size. Right, the size, right? The size. The size, which is times 2. Size minus 1. Or just size. Size is times 2, right? Not times 2 minus 1. Size plus 1. Oh my god. Size plus 2. I is... I not equals to 1. Okay. 1 because it's going down, I forgot. Hey, but hey, I managed to solve it. I cannot believe it took me this long. This is actually funny. I managed to solve it. It's the same. And if I go with like, let's say, it still works. It still works. It's a beautiful diamond because Z is 96. See, it's beautiful. It's just funny that it's. I know that there's a solution to this that's much simpler. This is like very verbose solution, right? There's a very verbose solution, but I'm sure there's a solution for this that's actually really simple. I'm assuming there's a pattern for this. Like there's a pattern for this. C is like 4, 3, and then this 4, 3. It's just I couldn't. Yeah, I know there's a pattern for this that's like simpler than my solution, but yeah. I know my loops. At least I know my loops. It's just funny. Okay. Moving on, since I was not able to solve this. That's why I did that. But anyways, moving on. Maps. Oh, maps. Like dictionaries. Dictionaries. Zero value of a map is null. A null map has no keys. No keys can be added. The make function returns a map to begin type. Okay. A zero value. So map is nillable. Map is nillable. Okay. Now I'm in maps. Slices are nillable. Maps. Map is nillable. Type. Okay. Returns null. Empty map. Nillable. nillable. Yeah, it's nillable. Nice. Nil map has no keys, nor keys can be added. Zero value. Okay. 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 Ready to use. Uh, no keys. Okay. This is interesting. There's something I want to check. What if I remove the make? Will this... Okay. Entry nil map. Okay. Interesting. Hmm. Map literals. But the keys are required. Ah, okay. Keys are required. Bell labs. Hmm. Vertex. Okay. Interesting. And you need to, since the type is string. Hmm. I'm assuming you can assign map to other types if that's the case. Map literals continued. I thought it was just a type name. Ah, okay, okay. Gets. I'm not sure when I would use a map though. I don't know. Like, ready map plus. Let's say. Struct xy int. Map. So var chord map plus map. top left. 0, 0. Let's say 15, 10, 10. And there needs to be a comma. Okay. Insert or update an element in key map. Okay, okay. It's the same. Retrieve an element. It's the same. So updating. Okay. That's interesting. I'll stream up to 2 p.m. So, okay. If okay. Interesting, interesting. Exercise maps. Okay. This is I remember I've had like an interview regarding but it was in Python, but it was dictionaries. It was a simple interview, but a simple problem. It involved dictionaries, but now it's involving maps. It's kind of the same. So implement word count. It should return each word in the string S. Implement the count of each word in the string S. So word count. Okay. RC equals map. Hmm. Okay. For each iteration of word, for word and range fields, if word plus word. Of each word. So you create a map. How do you it, first I need to create a map, right? I need to create a map. Hmm. Word map. Var word map is make map, right? Make map type, make map string int. And then okay. What's it again? Map key. Easy. This is easier than before. If this is wrong, I don't know. Yeah. Turn word map. Fail. Okay. Hmm. I wonder why it's wrong. Ah, that. What? It's still not working. I don't know why. Why is this not working? Let's go to trusty VS Code. Tree. The exercise command neat example test. Go code go. Main.go. And then go mod Heidi. And why is this not working? Wanna breakpoint this. Yeah. Yeah, it's correct. And then okay. I I hate myself. It's so oh yeah, it's fast. Easy. Damn. Damn. I hate myself. I was like wondering what was the error. That was funny. That was funny. Yeah, when you're so sure of your answer, right, and it's actually wrong. Functions are values, dude. They can be passed around just like other values. Make sure I can use a function against return values. Yeah, this is like very good. I think this is for dependency injection. Like you pass in the function, but I don't really know much about it. Yeah, I still have to read up on it. I just know that that term exists. Or when would you pass in a function? Decorators. Yeah. And at least in Python, you want to make a decorator. You pass in a function. I don't know why you would pass in a function here. And func float 64 float 64. Why would you do that? Fn, where's Fn? Fn 34. I don't get it. I don't get it. 81. Power of 3 and 4. 3 raised to 4. 3, 9, 27, 81. Hypoth, the square root of 3 times 3. 9 plus 16 is 25. Squared is 5. Okay. 13. Hypoth 5, 12. Anyways, I don't know why you would do that. Maybe I'm concerned about readability once you do this. Closures. Go functions may be closure. The reference variables are found outside its body. Closure. The function is bound to the variable. Okay. Other. Okay. Is it not like you're just renaming the function? It's bound to the variables, yeah. Some variable. I don't really understand this part, to be honest. I don't have a good understanding of it. I know I've tackled closure when I was learning JavaScript, and Python. Like at some point but like I think I need more. I need to read more about it. Yeah. So maybe that's my assignment. Read more about it. Yeah. This is like beyond. Okay, this is like the last one. Fine, I'll finish this and then I'll end the stream. It was only supposed to be 60 minutes. This is Fibonacci is a function that returns a function that returns an int. Okay. It's a function that returns a function that returns an int. Okay. So 0, so it's like if it's a function that returns a function that returns an int. Hmm? Okay, it's each closure is bound to its own sum variable. Kind of get that. That's what I. So it's like 0, 1, 1, 2, 3. The number before it, right? The number before it. It's just 0 plus 1 and then 1 plus 1, 1 plus 2, 3 plus 2, 5. It's n equals the num before it, so n minus 2 plus n minus 1 or something. Yeah. I think this is like the formula. And then if n equals to 0, just return 0. Else and then you return the function. I know this because I've done Fibonacci before. I've done Fibonacci before. I can show you that I've done it before. But like I don't understand the problem, like what it's trying to do. I don't understand. Let it go here. Oh, that's like let's do diamond. Then put diamond here. 3D dot diamond. Beautiful. Go modern net sample. Code main.py. Work? Okay, so works. Uh, do it how I would normally do it. Okay. So package main, so for it's usually like this, the end, or like the size, the length of the numbers, and then Fibonacci, let's say 10, and then I less than 0. You can do this, or you can do uh or you can do the recursive way. I'm not sure if Go is like good with recursion. Let's see if good is good with recursion. N-1. I think it's something like this. I forgot. I forgot. It's been a really long time since I've done any of this. Oh, okay. It doesn't terminate. Mm, mm, okay, okay. Ah, R 011. Start with 0 and 1. R that append. Like this. Then R. No, I don't need to start with I can start with 2. Right? R I plus R I minus 2 plus I. And just return R. Open this. I don't know if this will work. But this should work, right? This should work. I'm sure there's like a simpler solution to this. 0, 1, 1, 2, 3, 5, 8, 13. Easy. Yeah, but I don't. This is the Fibonacci that I know. And there's a recursive solution to this, which I forgot. But there is a recursive solution to this is much simpler. It's just a couple lines of code. But I don't understand what I'm supposed to do here. Like I don't understand. Really. Like I don't understand what I'm supposed to do here. So I'm just going to find a solution because I don't know. I don't know. I don't know. I seriously don't know. Like what the hell? Like why would you do this? Like you're not even passing anything to F. Is it like yeah, I don't get it. Because F is not changing. F is not changing. How would you know? And you're not passing I to F. If you're passing I to F, this would make sense. This would be a bit easier. But yeah, he's not passing I to F, which is kind of weird. Like Fibonacci is not taking in any arguments. Like how do you remember the state? Yeah, like how many times you've already added, right? Which index are you in? I have no idea. It's Golang exercise Fibonacci. What the hell is this? Okay. Mm. B minus A. I wanna take this in, right? I wanna take this in. And then I'm gonna put it in a in a breakpoint to understand it. Like, what the hell did he do? Hey, the exercises. It's not that, you know, the exercises are hard. It's more like I don't understand the problem. It's what it's like, what it wants me to do. That's what I don't understand. Maybe I'm just dumb. Maybe I'm just dumb. Exercise 4. This 4. And then code. Copy this. I wonder how you save the states. Like, this is like the thing that I really do not understand. Like, how do you why does this work? How? I'm sorry, okay? I'm so dumb. I'm so dumb. I know. Like, I don't understand why it's working. So you have F. Where do you save the state? Because it's not stored anywhere. So F equals, okay, it goes here. Why did it go here and not here? Huh. I don't get it. Like, you would expect the breakpoint to go here, but it skipped to the return statement. I mean, yeah. Why? I'm confused. I'm really confused right now. How is this storing the state? I don't understand closure. I don't understand. It's my assignment for next stream. I need to understand closures. Okay, I need to understand closures because I don't get it. So yeah. Of add 4 2 3 4 diamond. Anyways, I have to understand that it's 2:30. I still need to work tomorrow. I mean, today is Monday. I have work later. I still need to sleep. Yes, I have to sleep. I have to sleep, guys. Okay, I'm human, guys. Okay, I'm human. I have to sleep. I wish I could, live a life where I don't have to sleep, but no, I have to sleep. So yeah, thanks for watching. I've finished the tour of Go, but next stream I have to learn closures. So I think I'll what? How do I do it? Maybe I need to set a reminder. No. I'll just put it on my phone. You can see this is my phone. This is my phone. Okay. I'll put that as a reminder. I'll learn closures. So Tuesday. I won't be able to stream tomorrow because I won't be able to stream tomorrow simply because I have stuff to do. Yeah, I have stuff to do. So I'll just put an alarm and I'll set it to Tuesday. I'll set it to Tuesday, learn closures. So I need to learn closures, okay? Where is it? Let me set an alarm. Let me set an alarm. When do I stream? Maybe 9. 9 a.m. And then I need to set it to beats. Tuesday. Wait, you cannot schedule it. That is weird. One day. Okay, there. There. Can see? See? It's there. It's there. Okay. I'm not sure if you can see it, but it's there. So I have an alarm on 9 a.m. I put a label. Learn closure. Because I'm so dumb. I do not understand the closure. There. You see that? You see that? There's like learn closure. Like, I don't know if you can actually see it. I'm not sure if you can actually see it. I'm not sure if you can actually see it, but yeah. So yeah, I'll be streaming on Tuesday. Is it 9 a.m. or 9 p.m.? Let me double check. Sometimes I'm a dummy dumb. Okay, it's 9 a.m. Yeah, I have to go now. Oh, fuck. Thanks for watching. Bye bye. Okay. I'll end it properly this time. Okay, I'll end it properly this time. Don't worry, guys. I'll be ending it properly. Okay.